All right, here we go. So we're going to do problems 3 and 4 for your practice problems, right? I'll put up figure 3 and 4. Okay, so this says, and I'm not going to do all four, we're just going to do a hint. And the funny thing about this one here is I actually realized while I was looking through this problem that I kind of misled you guys on that whole like being less than one, like your answers for the first three, because this one gives us a value for tangent that's actually greater than one. So, I'm always interested in proving myself wrong about things, a little humiliating, but I'm not going to go back and remake all the videos. I'm just going to say that, it's we're all learning. Okay, so this says in a right triangle, the cosine of A is equal to 3 divided by 10. That's my ratio, right? So I wrote that down, and we got to remember that cosine is the adjacent side over the opposite, or not over the opposite side. God, talk about being wrong. Over the hypotenuse, right? It's over the long side. So your hypotenuse is right here. We are going to call this, for the sake of it matching the problem, we're going to call this theta right here. Okay, so that means that this is A. So the cosine of this angle, which means this side is A. Okay, and cosine, this is my adjacent side, and then my hypotenuse is 10. And so I got to find this, right? So we're going to do A squared plus 3 squared is equal to 10 squared. You always use the Pythagorean theorem to find that missing side if that's what you got to do. Okay, so this gives me A squared plus 9 is equal to 100. We are going to subtract 9 from both sides and get 91 is equal to A squared, and then we will take the square root of A squared and the square root of 91 to get to A. And A is square root of 91, and square root of 91 is not, you can't really simplify that, okay? Because it's none of our square numbers, if you think about the diagonal on a multiplication chart, go into 91, right? So with that, now we have established that this right here is the square root of 91. And so now that I know that, I can go ahead and find the remainder of my measures. So we've got sine of A, so that's going to be the opposite over the hypotenuse, okay? Excuse me. So the opposite is going to be this A, is what we just found. So it's going to be square root of 91 over my hypotenuse is 10. Okay, and get, I don't know why I'm rewriting it, but I am. All right, and now you'll see with tangent how when we know that it's opposite over adjacent, well, this is one of the cases where you actually do get a number bigger than 1 because square root of 91 is the opposite side, and it's dividing by 3, and that's going to give you something that's more or less like really, that's going to be a little bigger than 3. It's going to be 3 point something, right? So anyways, this is the answer. This is the exact answer for it. And just wanted to make a correction on myself to show you guys that I'm human and sometimes make some pretty dumb mistakes. And that was pretty dumb. All right, so here's our cosecant. So remember our cosecant is it is going to be, and I screwed up on this, which is why this is the second time making this video. It's the reciprocal of sine, right? Well, here's our sine. So it's hypotenuse over the opposite. I screwed up and started doing that, but that would be secant, right? So we want to do cosecant first. So our hypotenuse is 10, and then our opposite is the square root of 91, and we have to rationalize our denominator, right? So you get 91 on the bottom, and then 10 times square root of 91. All right, so that's that. Secant is going to be the reciprocal of the cosine, right? So it's adjacent, or sorry, it's the hypotenuse over adjacent. So when you do it, you can just flip it, right? 10 over 3, right? Hypotenuse over adjacent. And then our cotangent is taking our tangent and flipping it. So you got adjacent over opposite, running out of room here. And my adjacent angle is 3, and my opposite is the square root of 91. We're going to multiply both top and bottom by the square root of 91 to rationalize the denominator. So that gives me 91, and 3 times the square root of 91 right here. So that's how these problems are going to work. You're going to get numbers that are kind of like, what the heck, but that's all right, because in the real world, you would use a calculator for this to get to an actual number if you're trying to do this for some kind of application problem, and then it wouldn't bother you so much. All right, now I'm going to give you a hint on this one without actually doing the problem. So we got to look at what they're giving us. Is they're giving us the tangent, right? So if they're giving us tangent of something, we're gonna draw a triangle, okay? And let me think about this for a second. All right, so we're gonna go like this, and then we're gonna make the triangle look like this. Okay, so here's our right triangle. Okay, here is my side. All right, here's my hypotenuse, and we're gonna call this B over here, meaning that's the angle that we're dealing with. That's my theta, right? And tangent, if you remember, so the tangent of B is equal to 3. Well, that is equal to the opposite over the adjacent angle, right? So if you look at the number 3, you might have a slight panic attack and say, well, wait a minute, 3 is not a fraction. What am I going to do? Well, you can always write any whole number as a fraction. All you got to do is just put it over 1, right? So we're going to rewrite 3 as 3 over 1, and that's my opposite over adjacent. And so you can do this problem, right? It means that 3 is the length of that, and then my adjacent side is 1, and then you can use that information, figure out your hypotenuse. Once you figure out your hypotenuse, and this is actually one of the easier applications of the Pythagorean theorem, right? So figure that out, and then once you get that figured out, guys, you can go ahead and find your other measures using, the SOHCAHTOA, right? So you would do your sine, your cosine, you already know your tangent, and then you would go ahead and do cosecant, secant, and cotangent. So good luck with these, and have a little fun with it. I think relearning this, for many of you who learned it in geometry, and who dreaded it in geometry, I think that learning it when you're a year older and a year more serious as a student, I think is a lot of times really good, because it shows us that, hey, I'm starting to get this now. And that sometimes, you might not feel ready to learn something, but that doesn't mean you can't learn it. Just means that you maybe gotta revisit it. So good luck with these, and we'll see you in the next lesson.